In this OpenAI tutorial, you're going to learn how to use Python with the OpenAI API to do some really cool stuff. We're going to start at a high level and learn how to do text generation, text classification. We'll learn how to do language translation, maybe translate English to French. You're also going to create images, and we're going to learn how to create code. And once you have the high level stuff down, which we'll cover, and no worries, everything, I'm going to walk you through everything. We're actually going to do a mini project. We're going to take some Twitter tweets, is that the best way to say it, tweets, and actually fine tune a model to make it better at classifying tweet sentiment. So maybe you could use that in a trading algorithm, who knows? But regardless, the sky's the limit with this stuff. Maybe I probably shouldn't say this, but I'm actually having this technology read my email and respond to some of them. Okay. And quite frankly, responses are good, and it's a limited set of emails that I'm sending to, just promotional stuff. But anyways, the point is the sky's the limit with this stuff. So if you don't know who I am, my name is Leo Smigel. I'm an algorithmic trader that likes to use AI to empower my trading capabilities, and I like to code in general. So without me rambling on, why don't we go ahead and get started? Let's go to openai.com, click API. And then here you'll want to click login and then sign in with whatever authentication provider you want, either with Google or Microsoft. I'll use my personal Google account. And now go to the right-hand side, click View API Keys, create a new secret key, and here it should start with SK dash. You want to take this, copy, and paste it. And now that you have an API key, we can start making API calls. Now that we have our OpenAI API key, we're going to want to save it to a file. I'm going to use a .env file, and we're also going to want to install the software into a virtual environment. So let's do that now. OpenAI API key equals, and there's my API key. I'm going to write this to a file, .env, which we just, conventionally call it a .env file. I'm going to save this. I'm going to open up another tab so you can see exactly what I did. Right now we have a directory with just a .env file in it. And again, I can print this out and you see the OpenAI key value pair. And now what we want to do, now that we have our API key saved, is to create that virtual environment. Let's type Python 3 module venv. We're just using the virtual environment module to create a virtual environment called venv. Now, this will take 1 second here. I'll list this out. If you're on Windows or you're running into any issues, check the description below because it will be potentially different for your system, and I'll cover those in the documentation. So now that we've installed the virtual environment software, we can activate this virtual environment by typing source venv bin activate. And you'll see this venv appear here. Now what we need to do is install the software that we want. I'm going to say pip install and OpenAI, and we're also going to want to install the .env software. I believe that's python.env, so that way it'll load the .env file for us automatically. Now that we have our virtual environment loaded and our API key ready to go, open up your favorite editor. In my case, I'm going to use Jupyter Notebook, not because it's my favorite, but because I'm going to save this entire tutorial in a Jupyter Notebook that you're going to be able to download off of GitHub if you want to follow along. Now, authenticating with OpenAI is very easy. All we need to do is pass the API key into OpenAI after reading it from the system environment. So let's go ahead and do that now. We will import OS because we're going to use that to read our system environment. And our environment variables will import OpenAI because we're going to play with all of the cool models that they give us. And from .env, import load.env. This will just help us load the environment variables into our environment. And if it works, it's true. So now our API key is in the system environment. Now we'll grab that using OS. So API key equals OS get env OpenAI API key. And then we'll pass this API key into OpenAI. So OpenAI, it's like a tongue twister, API key equals API key. And then I hit enter. We don't know if that works yet. So let's go ahead and ask OpenAI. We'll make a request to the OpenAI API to see what type of models that we're going to be able to play with today. So we'll say models equals OpenAI model list. and then I'm going to print the models. And now we have this OpenAI object, and we can see here's a Babbage model, there's an Ada model, there's a Da Vinci model, and some other models too. So that did indeed work. We did authenticate. Now there's one issue here is that, whenever you do make a request to OpenAI, it passes us back this, model OpenAI model object. Now, what we can do is we can convert this to a Python dictionary list or a pandas data frame. So let's install pandas at the moment. So pip install pandas. I'm using a bang and then to pass this command to my terminal. If you're just running on your terminal, you just type pip install pandas. You may already have it installed. But now that that's installed, I can use pandas to make this easier to see. So I'll import pandas as PD, and then data equals PD data frame models, which we just got from that request. And I'll just say data here, and then data.head, and then this should give us a easier to see list of all of the models. So now that we're able to make a request to OpenAI and see the various models, let's talk about the OpenAI model types. OpenAI classifies their models into 3 distinct families. The first is the GPT-3 or Generative Pre-trained Transformer 3 models. This is essentially what ChatGPT is based on and, set the world ablaze with all the cool stuff it can do, even though GPT technology has been around for a while. There's the Codex family, which is great for code-specific tasks, such as, give me a program that does X. And then finally, there's content filtering, that essentially allows you to understand the whatever it's saying and whether it is malicious or not, even though OpenAI at this point is actually recommending to use the content moderation endpoint. Primarily we're going to be focused on the GPT and Codex models. Now with the Codex, the GPT models, there's 4 of them, and listed in descending order of both price and capabilities. There's Da Vinci. So if you can, Da Vinci is what ChatGPT is based on. It's a specialized, fine-tuned version of that, and it's pretty much excellent. At least, relatively speaking. In a year, we'll probably say, "Oh, these are terrible," but it's excellent for doing pretty much anything with natural language. Below that is the Curie model that is pretty good too, but at a cheaper price point. Then you have Babbage and then Ada finally. And then we'll use Ada in our experiments because, well, it's the cheapest for fine tuning. And then with the Codex model, there's 2. There's Da Vinci, again, the most capable. And then there is the Cushman, which is, less capable, but faster and cheaper. So that begs the question, what model do you choose? Well, here's an easy way to find out. Let's head back to the OpenAI website. We'll go to openai.com/API. We'll click Login. And then once we're logged in, we should see a few links at the top. We're going to want to click on Playground. This Playground lets you essentially test all the models out to see whether or not they work for you. So we could, select a model here. We'll try out Ada. I'll say, give me an engaging way to ask a YouTube audience that is currently watching an amazing OpenAI API Python tutorial to like and subscribe. Let's see what it says. Now that took, use OpenAI to create Basicables panel. Yeah, not so hot. So we can say, okay, well, this model might not work out so well. We'll use Da Vinci because, we know that works for pretty much anything. If you found this OpenAI API Python tutorial helpful, please be sure to hit the like and the subscribe button to stay up to date on all of our amazing tutorials. I agree with this 100%, but you see the point here, right? You don't want to start programming using this Ada model to find out where intrinsically it just doesn't work very well for what you need. So that's the best thing to do is before you start coding, come to the playground, play with what you're trying to figure out, whether it's sentiment code, whatever, and then start on coding. We'll start by performing some basic NLP or natural language processing tasks, such as inserting and generating text. Now, all of this stuff that we're going to cover is actually very easy. One of the more difficult things is actually determining what you really want the AI model to do. That is, prompt design. What we ask the model to do is the prompt, And there's so much depth to prompt design. There's actually entire YouTube channels dedicated to various prompts, right? And if you bend down this rabbit hole and you start really digging in, you'll see that there's so many cool things that you can do with these models. But I don't want to digress too much. My point is, whenever you're creating these prompts, take a step back and think about exactly what you want. Remember, you're not having a conversation with a friend. You are trying to tell or use natural language to tell a computer model, hey, take this, turn it into code and run it for me, right? So think about it that way. You have to be very precise and very clear with what you're telling these models in order to get the result that you desire. We'll start with text generation and completing some text. As you'll notice, it is so easy to do, almost embarrassingly so, which is amazing because these models are so powerful and accessible to almost anyone. So we'll say text equals OpenAI dot completion dot create, and then we'll pass it the model. Model equals text DaVinci 003. The prompt will say France is famous for its. We'll say max tokens, and tokens are essentially the currency for these models. One token is 4 characters, I believe, or roughly 0.75 of a word, or 75% of a word. So you can think of a 750 word article being about 2 cents. I believe that's roughly speaking about correct. So then temperature is essentially creativity. We won't make it creative at all. And let's see what this Da Vinci model gives us. France is renowned for its rich food and varied cuisine, which is, and it cut off because we only had so many tokens. And if we wanted to, we could actually get some more responses for this, right? So we'll say for, whatever in range. We're just going to throw away the one for this right here. The underscore is conventional for whenever you're throwing something away and not using it. And then text equals OpenAI completion dot create. And then we'll just take the same exact stuff that we had up here. Although I will increase the model limit this time so we can get better responses. We'll just say, 100. And then we'll say print. Make it a little easier to see. Text choices, right? And you can see here, we have this choices right here, which I'm accessing. Then I'm going to access the first one, and then I'm going to access text. So choices 0, first element text. Okay. So choices 0 text, and then I will print, let's do this, print. And then we should see a list of choices and responses. So we'll see if that does indeed occur. Okay, France is famous for its rich and varied cuisine, which is renowned for its fresh ingredients, classic techniques, and flavorful combinations. So you can see popular dishes. Yeah. So it does vary these, right? So that's interesting that you can have these, 5 responses. If you don't want to do it this way, which I don't suggest you do, you can go back up here, copy all of this. I'm going to create a new row here. Let's see here, this, and we can just go, comma, n equals 5, make it interesting. And I'm actually going to make this smaller so it's a little easier to see. And then we can print this. And now you'll be able to see you have a bunch of various outputs, right? So you don't actually have to loop through. You can just give it, n times. So that's pretty easy to do, right? But what about text generation and sentiment analysis? Well, I'm glad you asked. As I said earlier, the API is super easy to use. And in fact, we do both of these things with the completion create method. So let's give it a shot. Give me a funny tagline for a YouTube channel that discusses trading and programming. I actually have two channels. The one's dedicated to trading and this one's dedicated to programming, although with, algorithmic trading. I'll just do n equals main programming, trading, and not boring. Yeah, that's funny. Okay, because, well, some of this stuff to many can be boring. But anyways, you get the point. We can also do the same thing for sentiment analysis, right? So whether it's a tweet or classifying and if an email is spam or not. So is the following email ham or spam? Ham is a good email. Spam is a bad email. You have won the $1 billion lottery. All you need to do is click the following link. And it should give us spam. This is most likely spam. That's right. Now let's try it with a different model, ADA001, which is the cheapest, least capable model. The following email is spam. So it actually classified that. Let's see if we can trick it. Okay. What is the sentiment of the following tweet? I'm really happy that the movie ended early. I didn't enjoy it. Maybe that'll work. See, I'm trying to throw in happy there. Let's see. So is it positive or negative? The sentiment of the following tweet is in units. Okay, clearly not what we wanted. Didn't see if this will give us negative. All right, so you get the point there, right? So again, that's why I said, use the playground to determine whether or not the model really even makes sense. I might not use ADA unless, I was really concerned about the cost and probably fine tuning, which we'll do a little bit later. So now that we know how to do all of the, text generation, creating, inserting, and determining the sentiment, let's talk about editing text. Now, I do a lot of reading, and maybe it's just me or I'm weird. Actually, I know I'm weird, but hey, we're all unique in our own way, right? When things are in passive voice, it bothers me. Okay, I guess it just stuck with me, my English class. So let me copy some text. And in passive voice, a car was bought by John, a car was hit by a truck, the website was developed by ABC. And what we'll do this time is we'll take this text and we'll ask the model, in this case, we'll just do DaVinci Edit 001 to edit the text into active voice. Let's say response equals OpenAI. This time we're not going to use create or completion, right? We're going to use edit and then create. So all of the, we're using the create method, but we're using, the edit class. Okay, so then we'll say model equals, this is a little bit different, text DaVinci edit 001. Input equals input text. Instruction will equal convert the sentences into active voice, and temperature equals 0. And now what we need to do is we'll just loop through this to make it easy to read. We'll say for choice in response choices, print choice text. And when I run this, it should convert each one of these into active voice, right? So John bought the car. A truck hit a car. ABC developed the website, right? You see who's performing the action now. So that's simple and easy to do, and you can do this for pretty much any text. It's pretty amazing. And what you can also do is you can actually say, give me the prior sentence or the old sentence plus the new sentence. You can say, convert this to easier to read, use it in a different voice. If you want to be salesy or, whatever, you could use the voice of Gary V, but you can do all sorts of things for editing and modifying text. It's pretty amazing. But now that we've sort of covered everything from a natural language perspective, again, super easy to use. You're either going to use the, completion module or the edit module and then the create methods. Now let's talk about using Codex models to do some code completion. Code completion is essentially the same as natural language completion. The only difference is that we're going to use one of those specialized Codex models. If you recall, there are two of them. There's the DaVinci model and the Cushman. The DaVinci is more capable. So let's give the DaVinci a spin. So what we'll do is we'll ask the model write a Python function that accepts the first name, second name, and birth date as parameter values. Well, you know what? I'll leave the typos in there, and returns the full name and the number of days from the birth date till today. And as I mentioned before, it's essentially the same as the completion. Completion create, only this time we need to change this to completion. And the model is not text, it's actually code. All the codecs start with code. DaVinci 002. It's not input text because that's for edit. It is prompt. It is prompt text. The instruction is the prompt, so we don't need that. Temperature is 0. We don't need to get creative. And max tokens equals 2048. And then we will run this and see what it does. And sometimes this can take a minute. And let's see what it gives us. We've got import date time. We have the full name. It returns the full name. This function returns the full name and the number of days. So full name is first name plus space, second name, birth date, today, days, return full name, days. So it looks like it does indeed work. So that's exactly what we wanted. But what happens if we are stuck on a programming problem where we actually want to, complete or insert code, right? So let's give this a shot. So what happens if we do this? And I'm going to let you try to guess at the response here. So prompt text, this just tells it we're going to use Python 3. And then response equals OpenAI completion create. We've been typing that a few times, right? That's basically all you need to do and know the models to use. Model equals code. We'll use DaVinci again. DaVinci 002. Prompt equals prompt text. Remind me next time to just copy and paste again. It's easier. And max tokens equal 2048. And suffix equals return x times x. So what do you think this is going to print out, right? I'm going to pause here and let you think about that for a second. It could actually be very, very short. We'll see. We'll see what it does. Okay, here I go. Oh, of course, there's an error here. Prompt text equals. Yeah, it is very short. So what it did is def square, and then we return x times x. So it understood that this was, the square function and knew to put def square ahead of that. Now we can actually use, the same pattern as before, how we went from creating text to editing text. So let's edit some code here. So what we'll do is we'll type in prompt text equals def process x and then return x times x. In fact, let's see, I'm going to just make it not as nice and see if it figures that out. Response equals OpenAI. And again, this time we're using that edit module again for, to edit stuff as opposed to create. Model equals code Vinci edit 001. Notice the model change. Input instead of prompt. Prompt text, maybe I should say input text for the Jupyter Notebook. Scroll down a little bit. Temperature and instruction equals modify this function to return the cube of the input parameter. And we'll go ahead for choice in response choices, print choice text. And let's see what it gives us here. Okay, def process. So it does know how to modify this from return x times x, and it actually did adjust the x to returning the cube. So obviously these are pretty basic examples, but you get the point. You use the Codex model whenever you're working with code. And you can either use the completion or the edit classes or models, whatever you want to call modules, whatever you want to call them, to edit that code. That's essentially what GitHub Copilot is doing. So now that you understand how to edit and create both natural language and code using the OpenAI API, let's see what we can do with some image processing and creation using the DALL-E models. Image creation is just as easy as natural language or code creation. We're going to follow the same process. First, we're going to learn how to create images, and then we're going to learn how to edit them. Now, if you're interested, DALL-E is just a portmanteau or a combination of Salvador Dali and the Wall-E Disney film or character. I'm not sure which one, maybe both. I haven't seen it. But all we do is we give natural language to OpenAI and it returns an image of what we want. So let's give it some prompt text of a dog standing on the beach, and we'll follow the same process. So we take the response, and this time it's OpenAI image, not completion or edit, create. And we don't actually have to pass it a model. We just have to pass it a prompt and the size. So prompt equals prompt text. And we'll say 2 and size. And I should mention at the time of this video creation, there's 3 sizes. There's 256 by 256, 512 by 512, and 1024 by 1024. We'll do 512 by 512. And then for each image, we'll print out the URL because the image won't actually just show up on your computer. It'll be stored as a URL on Microsoft Azure. For image in response, data, print, image, URL. And let's see what we get here. I'm going to open these up and hopefully we get a dog standing on a beach. Let's see. Perfect. So there's a dog looking at the beach, looking like he might jump in or lost his favorite ball. And then here's another one playing in the sand. So that's pretty impressive that they just generate these images. I mean, if you look really closely, you can kind of tell these are AI generated images, but it's only a matter of time before reality and, these generated images become almost indistinguishable. All right, so now that we know how to create images, let's learn how to edit them. Image editing is pretty much as easy as image creation. The one thing that we do need to do though is pass 2 images. One is the original image and one is the mask. You can see here, I have a dog on a beach. And then here we have a mask, which is pretty rudimentary. I'm sure you can do better if you have more artistic skills and access to Canva or Photoshop or whatever. But the point remains the same. We just need to pass it original image and a mask of where we want to adjust our image. So let's go ahead and create that edited image. We'll say response equals OpenAI image create edit, and then we pass it both the original image first and then the mask. So image equals open. The file is located in home, Leo Smiggle, downloads, dog.png for me, and then we want to read binary because this is a binary file. Yours might be different, your path rather. And then the mask for me is dog-mask. The prompt will be, okay, let's see, prompt equals a cat standing on a beach. So we'll change this from a cat to from a dog to a cat. We'll make n equals 2 and size equals 512 by 512. So the same as the original image. And for image in response, data, print image URL. And then it'll give us some URLs on Azure where we can see if this did indeed change this original image from a dog to a cat. And let's open these up. 1, 2. Let's see what we've got. There is a cat standing on the same beach, as you can see, and here's another cat. Clearly AI generated, but again, as this technology matures, I think it'll be indistinguishable from reality. But maybe what you want is not to edit an existing image with a mask. Maybe you just want variations of an existing image, and that's very easy to do with OpenAI too. This will be the last thing we do before our mini project, and all we need to do is the following. So OpenAI image create variation. say image equals open, I could spell, pass it the original dog image, home, Leo Smiggle, downloads, dog.png, and we want it to read the binary. We'll say n equals 2, we'll get 2 of these, and size equals 512, we'll keep it the same. And then for each of these images, we'll print it out. So for image in response data, print image URL. And this should give us 2 URLs on Azure with the dog on a beach with different poses. 1, 2. So here we see the dog on the beach, different poses. That's the cat. So here's that dog that was modified, and it looks pretty similar. It looks like the same dog, although that's not. You might, if someone looking at this, be like, that's clearly AI generated, but I digress. So now that you know how to create and edit images and create variations of those images, create and edit code and insert code, and also do the same thing with natural language, you have a full understanding of all of the basic, OpenAI API endpoints. Obviously, there's Whisper and other things which we're going to cover in different videos. But for right now, you have a complete understanding of all the basics. Now it's time to learn how to fine tune an existing model and get it better at understanding tweet sentiment. So let's go ahead and embark on this fun little mini project. Before we dig into this mini project where we're going to fine-tune an existing ADA model using tweet sentiment data from Kaggle, let's take a moment and think about why in the world we'd want to do this anyways. Well, these GPT-3 models are trained on massive amounts of data, and this data affects the model weights. If you're curious on how this works, look up neural networks and backpropagation. We're not going to discuss this here, but for our intents and purposes, you can think of these things as a big number with lots of different weights for various inputs. And essentially, maybe that's not helpful, but the point is, what we can do is we can take specialized data for our use case, feed it to these already existing models. We don't have to create a new model from scratch. We can take all of the work we've done and just tweak our stuff for our specific use case and to improve our model. And there's really two reasons you want to do this. One, the existing model isn't performing the way that you want it to, or two, you might even be able to use a lower cost model such as ADA to be able to analyze the sentiment at a much lower cost. So first, we're going to get the data from Kaggle, and then we're going to use the OpenAI CLI to format the data appropriately. Then we're going to fine tune, and let's dig into the code. We'll first want to go to kaggle.com, Kaggle.com, so we can download the Twitter US airline sentiment so we can fine tune our ADA model. If you're not familiar with Kaggle, Kaggle hosts data science competitions, and the community rallies around these competitions, so you can see some of the latest and greatest techniques in data science. If you're interested in data science, Kaggle is a great website to check out. Here is a link. I will leave this in the description below to the data I've already downloaded. I'm going to zoom out a little bit, and the first thing you want to do anytime you have a new data set, obviously, is to fully understand it and explore it. So let's import pandas. We'll read the CSV file. Once we have an understanding of the file, we'll format it in a way that OpenAI expects, so that way we can pass it to the CLI to upload it to OpenAI. So let's first import pandas. Import pandas as PD. Say data set equals pd.read CSV. I downloaded my file to home, Leo Smiggle, downloads, tweets.csv. And let's go ahead and print out the first few rows. We can see the tweet ID, airline sentiment, confidence, negative reason, confidence, airline, all sorts of information. But we're primarily concerned about in regards to the text of the tweet itself and the sentiment. Right, so the text and the sentiment. So let's create a new data frame using just that. Say df equals dataset.filter. We'll grab the text, the text and the airline sentiment. And then let's print out the head. So now we can see we have the text here and then the airline sentiment. Now, I don't want to train the ADA model on all of this data because it's going to take forever, and I'm also cheap. right? At least for this case, maybe for something in production, it can be a little bit different. But for our intents and purposes, I'm going to make this smaller. You can choose to make it as small as you want or keep the size, whatever. But we'll do df shape. And we can see that it is 14,640 rows and 2 columns. I'm going to make it, let's say 1200, right? So we'll say df, we'll slice it 1200, df equals, and then df shape. Okay, so now it's only 1200 rows. Now there's one last thing that we need to do before we save it to a CSV file for the CLI to import, and that is to change the column names. df dot columns equals, and it is prompt and completion. And then df.head, see if that's correct. So prompt and completion. So now we have 1200 rows formatted in the correct way. So let's save this to a CSV without the index, and then we'll be able to import it to the CLI. So df.to CSV, I'm going to say home, Leo Smiggle, downloads, airline, sentiment.csv, and the index equals false. And I'll save that, and now we'll have the file to import into the CLI. We want to open up our terminal and make sure that our virtual environment is active, so that way we have access to the OpenAI CLI tools. I'm going to activate mine now. And I see now that it's active because I have this virtual environment prepended here. And now I'm just going to pass my file to the prepare data command. Let's do that now. OpenAI tools, fine tunes, prepare data -f, and my file is at home, Leo Smiggle, downloads, airline, sentiment.csv. And then it's going to ask us a number of prompts. Prepare, what did I do here? I don't know what that is. PREPARE. All right. So it's going to ask us a few prompts. We're going to want to remove the duplicate rows. We're going to want to add the suffix separator. We do want the white space character at the beginning of the completion. We do not want to split it into training and validation sets for this tutorial. And then we will save this to a new JSON file that will be the same exact format or same name as our airline sentiment file. It'll just have a underscore prepared.jsonl file. So with the file in my downloads folder, now I can import this and create a training file and then pass that to OpenAI. You'll notice here that model training does take some time. For a Curie model, takes right now around 31 minutes. It'll take a little less for Ada and Babbage, but this process does take some time. Let's go ahead and train our model now by heading back over to Jupyter Notebook. We'll now create the training file from the prepared data. I'm going to paste this function in here just to speed up the process so you're not watching me type. All we're doing here is creating a file using openai.file.create, passing in the file path from here that we pass in as a parameter as read-only and binary, and the purpose is fine-tuning. And then what we'll do is we'll take that file, training file equals create training file, and we'll pass in our existing file. So home, Leo Smiggle, downloads, that's airline sentiment underscore prepared.jsonl, and then print training file, and then scroll down here, and we can see that it is indeed creating this file. And what we're primarily concerned with is this ID here. So I'll just take training file, and then ID, and this will give us the ID. And we're going to use this ID to train our Ada model. With our training file ready to go, training the model is actually pretty easy. All we need to do is pass the training file ID to the OpenAI fine-tune create method. Let's do that now. So fine-tuned model equals OpenAI fine-tune create training file, and then here's the training file ID, not the actual file itself, training file ID. And we also want to pass it the model. I'm going to pass it the Ada because it's the cheapest. DaVinci can be pretty expensive for fine tuning. And the number of epochs you don't need to pass. I'm going to just do it anyways, just so you can see. Epochs equals 4. That's actually the default. And now that we have that, print fine tuned model. And you'll notice this created this prints out relatively quickly. Let's take this ID and we can get status updates on it. We do this by typing OpenAI fine tune list events ID equals the ID from this, and then data. And we can see here that we've just created this fine-tune event. This is going to take some time. And once it goes through the entire process, we'll see a final message that says fine-tune succeeded. So I'll see you when this is done. The fine-tuning is finally done. I say finally because it took over 3 hours in queue. And then once the fine-tuning started processing, it was relatively quick. So now that we have the fine-tuned model, let's test out the original Ada model to see if it misclassifies our tweet, because if it does, we did all this training for no reason. So hopefully we'll make a fool out of me on YouTube. We'll see. Give me the sentiment of the following tweet. The flight landed ahead of time. The food was delicious. Okay, so that seems pretty positive to me. We'll just use the completion create, which we've done 100 times now, to analyze this. So response equals OpenAI completion create. We'll take the model. It's the text Ada 001. Prompt equals prompt text. The max tokens we'll give 5, and temperature equals 0. And now what we'll do is we'll just print out the response. Print response. We'll take the first choice and print out the text. And it definitely shouldn't give us positive, negative, or neutral. And thankfully it doesn't, right? So it's just printing out the flight landed ahead of time. Now what we can do is we can scroll up to the output of our fine tuning, copy the model name, and I'll show you how to get this model name a little bit later if you don't actually have the output in front of you. And you paste it in here, and we cross our fingers so that it doesn't make me look like an idiot on YouTube. Positive, positive, positive. So it is positive, thankfully. Whew. Okay, so you can see that the original model did not work, but the fine-tuned model did. Now let's try something else. The flight landed ahead of time. Food was delicious. I'm going to delete this. And I'm going to say the flight landed on time. Let's see if it's smart enough to know this. So we obviously know the regular Ada model doesn't work. Let's see if this can classify as neutral. Flight landed on time. I guess that's sort of positive. The flight landed behind schedule. Negative. Okay, so we might have needed to train it with some more data, but long story short, we can see that our fine-tuned model is definitely giving us better results than the standard Ada model. Here's a challenge though. I mean, I guess it's still at a lesser cost, but what happens if we just change this to text DaVinci 003? Oops, what did I do here? Text. There we go. Frustration. Wow. Okay. So that's interesting. Let's see if it can classify the flight landed on time. Positive. Okay. Yeah. So you can see that the DaVinci model worked better than even our fine-tuned model, although it, costs more per token. The key here is understanding, do you really need to fine-tune a model? And why are you doing that? Is it because you want a reduction in price, or do you really need to improve the model? You now know how to create, or I should say fine-tune, an OpenAI model to improve it. That's pretty cool, right? But what happens if you wanted to create your own model, use some of this tech in your own models? Well, enter OpenAI's text embedding. So let me just create a new section here. Say text embeddings model. And this allows you to, well, actually, I should take a step back. What are text embeddings? Well, text embeddings, we can see here, is essentially a computer can't be trained on text. It doesn't understand text. It just understands numbers. And what this does is it takes this text and translates it into a vector. Think of like 1560. I forget exactly how long, but essentially what this text is it converts this text into a vector. It shows sort of like the relationship is right. It's not just an ASCII conversion. It's a relationship of this text to here. How OpenAI does that is beyond the scope of this, but just understand that this text is converted into a vector. Now, and we can use that vector to train our models, right? Each float can become a feature. So let's see exactly how we'll do that now. Let's go ahead and create some input text. Input text equals the flight was on time and the food was delicious. And then, as you know, the OpenAI endpoints are super easy to use. So response equals OpenAI, and here we use the embedding. Create model equals, and this is text embedding ADA 002. It's their latest. You can read about it if you're interested right here. You can just search for this OpenAI text embedding ADA 002 model, and it'll tell you all about it. Input text. So all we're doing is we feed it the model, we feed it the input text, and it'll respond with the embedding. I'm going to print out this embedding, and the length, Arias Ponce. Funny trying to talk and at the same time I'm having difficulty apparently. All right, embedding. Perfect. So this will print out the length of the embedding. Now let's actually just print out the embedding itself. And then, so you should see a length and a large list of floats. Okay, so we see 1,536 essentially features. You can kind of think of it that way. It's the 1,536 dimensional vector, which is the text embedding, ADA 002 model size. So now how do we use this? Well, let's go ahead and train our classifier with the GPT-3 embeddings. The first thing that we'll do is we'll create a function that takes the text and turns it into an embedding. Easy enough. Let's do that now. So def get embedding. Pass it the text and the model. And text equals text.replace. We're going to replace the new lines with spaces and return OpenAI embedding create, and the input equals text and the model equals model. And we don't want to return the entire response. We just want the actual embedding. So I'm going to get the data, first element, embedding. Perfect. So that'll get us the embedding. Now what we need to do is read in the tweet sentiment data that we downloaded earlier and apply this function to some of the fields into the ADA embedding column. So that's easy enough too. So what we'll do is we'll say dataset equals PD read CSV. Mine is at home, Leo Smiggle. Downloads, if I could spell, tweets.csv, so that reads in the file. Now I don't want all of the columns, I just want the text and the sentiment column. So dataset equals dataset filter, text, and airline sentiment. And now I don't want all of the records because I'll get rate limited, right? You can only, I think there's only 60 API calls a minute. So let's just do dataset equals dataset.head, do 50 at the moment. And now we want to create our ADA embedding column. So dataset dataset ADA embedding equals dataset text dot apply, and then we're just going to pass in the function x, where x is the text, get embedding, and we'll say x is the text and the model is the text embedding ADA 002. And now let's just print out a sample of this dataset head to make sure we got it right and see what happens. And now we see that the data frame printed out, we see the text and the airline sentiment, and this text turned into an ADA embedding here. Now let's create our train and test set so that way we can fit our model. First thing that we'll do is we'll create our features. So x equals data set ADA embedding. And now this is currently a series, so I'll make this a list. And I can print this out and you can see it's just our float values, essentially the text, which is the ADA embeddings right here. And now what we want to do is we want to encode the sentiment. So we don't want to use neutral, positive, and negative. We want these to be zeros and ones. We don't have to do that manually. What we can do is we can use sklearn's label encoder to do this. So let's do that now. So from sklearn, import pre-processing, and then LE, which is simple or short for label encoder, pre-processing, label encoder, and then y equals LE, fit, transform, data set, and now we want the airline sentiment. Line sentiment, and then I'll print this out, and you'll just see a bunch of zeros, ones, and twos, which are essentially the neutral, positive, and negative encoded. Now that we have this, what we can do is split this into train and test sets. And again, we're going to use sklearn. From sklearn, model selection, import train test split. And now what we'll do is we'll split them into four variables: x train, x test, y train, and y test equals train test split. X, Y, we pass the X and Y in, and then we just give it a percentage of how much that we want as our test size. I believe the default is 25%, but I'll just put it here anyways. And random state, or be explicit about it. And random state allows us to reproduce our results. I'll just put 42 here, and then I'll run this. So now we have in each one of these variables, 75% of the data to train on and 25% to test on. So now let's train. We will use a random forest classifier provided by sklearn. So from sklearn ensemble import random forest classifier, and RFC equals random forest classifier, creating the RFC object. And now what we'll do is we'll fit it. So RFC fit. We fit it on the training data, obviously, right? So what we're doing is we have this X train, which is all of this, and then we, fit it to the Y, which are the, the sentiment. So we run this, and what do I do here? sklearn. Oh boy, I spelled this wrong. I'll copy and paste this. There we go. Guess I did. All right, now we have that. Perfect. Okay. Typos aside, things were going well. All right, so now what we do is we have this fit random forest classifier model. Now we want to perform some predictions. I know that the test isn't going to be that great because we don't have a lot of data. I did that purposely because unless you have a subscription, you're rate limited at 60 API calls a second. And I didn't want this video to take too much longer. So now what we'll do is we'll say RFC pred, which are just the random forest classifier predictions, equals RFC predict. And now we do X test. So we're passing in our X test and see how we get, how well we predict the Ys, right? So I'll run that. And now what we need to do is print the results. So I'll say from sklearn metrics, import classification report and confusion matrix, print confusion matrix Y test RFC pred, and we'll do the same thing for the classification report. Y test and RFC pred. All right, so as we can see, 38% accuracy, still, better than a coin flip, because if you think about it, we've got, 3 variables that we're trying to predict. I guarantee you if you give it more data, it will get a lot better. So that's pretty cool. You now know how to take this ADA embeddings and use it for your own prediction models. We can also perform zero-shot classification using the GPT-3 embeddings. What this means is, we can predict things on, based on data that we haven't seen. We can use the OpenAI Embeddings util cosine similarity for this. Now, let me know if you like this method better. If you followed along this far, I really appreciate it. Tell me if you like me to, see me type it and talk about it, or if I can just copy and paste which method you prefer. So basically here, we're just importing the embeddings util cosine similarity. Then we have to get our labels, which we're familiar with. They're just positive, negative, and neutral. Now I'm going to use list comprehension to pass, everything through that get embedding function that we created earlier. The model's still going to be text embedding ADA. So for each label in labels, run this function and return it. So essentially we're going to have, data for positive, negative, neutral for each label. And this will become more apparent as we see the data. Now we need to create a function for each label score that will call this call our get embedding function. So I'll copy and paste this here. And what you can see here is we're returning the cosine similarity between the text, which is the tweet, and then the label embeddings. Okay, so let's run this, assuming I didn't make any typos, which I will not guarantee. Okay, and now what we'll do is we will, get the label scores for this. So label scores equals label score. That's the function right here. Pass in the review text. The flight was awful and the food was really bad. Obviously pretty negative. And then what we need to do is pass in our label embeddings. So label embeddings, and then we'll print out the label scores. And you'll see here that we have 3 scores, right? And now what we can do is we can select the max index, essentially the max, and then the index to determine which label it was. So we can see here, label scores.index max, it'll give us the max value, returns the label's max index, and in this case, it should be negative, which indeed it is. So that's it. If you followed along this long, congratulations. You're one of the few. You've learned all of the basics, and now you also know how to do fine tuning. You can use the embeddings and train something on your own machine, and you can even perform zero-shot classification with embeddings. Hopefully you enjoyed this video. If there's anything else that you would like to learn, let me know in the comments below. The next one, I'm probably going to do some earnings call analysis using OpenAI, for sentiment analysis, and also OpenAI's Whisper. So hopefully you enjoy this one. Hope to see you in the next one. Thanks. Bye-bye.